discovered a few days ago signs of water and carbon monoxide gas detected in a galaxy far, far away by ALMA scientists. This is by Amy Oliver, National Radio Astronomy Observatory. Water has been detected in the most massive galaxy in the early universe, according to new observations from the Atacama Large Millimeter Submillimeter Array, ALMA for short, in the Atacama Desert. Scientists studying SPT 031158 found H2O, which is water, along with carbon monoxide gas in the galaxy, which is located nearly 12.88 billion light years from our Earth. Detection of these two molecules in abundance suggests that molecular universe was going strong shortly after the elements were forged in early stars. The new research comprises the most detailed study of molecular gas content of a galaxy in the early universe to date, and the most distant detection of water in a regular star-forming galaxy. And the research is published in the Astrophysical Journal. And this is November 3rd article. SPT 031158 is actually made up of two galaxies and was first seen by ALMA scientists in 2017 at its location or time in the epoch of reionization. This epoch occurred at a time when the universe was just 780 million years old, from what they believe, roughly 5% of its current age, and the first stars and galaxies were being born. Scientists believe that the two galaxies may be merging, and that their rapid star formation is not only using up their gas or star-forming fuel, but that it may eventually evolve the pair into massive elliptical galaxies like those seen in the local universe. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Using high-resolution ALMA observations, the Atacama telescopes, of molecular gas in the pair of galaxies known collectively as SPT 031158, we detected both water and carbon monoxide molecules in the larger of the two galaxies. Oxygen and carbon in particular are first-generation elements, and in the molecular forms of carbon monoxide and water, they are critical to life as we know it, said Giovanni Jarugula, astronomer at the University of Illinois, the principal investigator on this new research. He said this galaxy is the most massive galaxy currently known at high redshift, or the time when the universe was still very young. It has more gas and dust compared to other galaxies in the early universe, which gives us plenty of potential opportunities to observe abundant molecules and to better understand how these life-creating elements impacted the development of the early universe. Now, water in particular is the third most abundant molecule in the universe after molecular hydrogen and carbon monoxide. Previous studies of galaxies in the local and early universe have correlated water emission and the far infrared emission from dust. The dust absorbs the ultraviolet radiation from the stars in the galaxy and re-emits it as far infrared photons, said Jarugula. This further excites the water molecules, giving rise to the water emissions that scientists are able to observe. In this case, it helps us to detect water emission in this massive galaxy. This correlation could be used to develop water as a tracer of star formation, which could then be applied to galaxies on a cosmological scale. Studying the first galaxies to form in the universe helps scientists to better understand the birth, growth, and evolution of the universe and everything in it, including the solar system and our Earth. Early galaxies are forming stars at a rate thousands of times that of the Milky Way, said Jarugula. He says studying the gas and dust content of these early galaxies informs us of their properties, such as how many stars are being formed, the rate at which gas is converted into stars, how galaxies interact with each other and with the interstellar medium, and more. According to Jaragula, there's plenty left to learn about SPT 031158 and the galaxies of the early universe, saying this study not only provides answers about where and how far away water can exist in the universe, but also has given rise to a big question. How has so much gas and dust assembled to form stars and galaxies so early in the universe? The answer requires further study of these and similar star-forming galaxies to get a better understanding of the structural formation and evolution of the early universe. So this exciting result, which shows the power of the Atacama, the ALMA telescopes, adds to a growing collection of observations of the early universe, said Joe Pesce, astrophysicist and ALMA program director at the National Science Foundation, saying these molecules, important to life on Earth, are forming as soon as they can, and their observation is giving us insight into the fundamental processes of a universe much different from today's. This is by National Radio Astronomy Observatory on phys.org. Please leave your comments. Thank you for your support.